Good afternoon. We're Group 17. Our design project is middle school robotics kit specialized for middle school students. My name is Jeancarlo Casasola.
My name is Diaz.
My name is Senyk.
All right, so basically the purpose that we found for this design project was to provide a robotics kit specialized for middle school students. We wanted to provide something that was kind of modular, something that had various stages to it, whether it be the design process using both robotics kits or the programming process using different types of languages. We also wanted to provide kind of an outline because we hope that future groups follow on our path and kind of add on to our designs. So why did we do this? We saw a general trend moving towards robotics kits in general. Like I know over this past Christmas break or over the past break for Black Friday, there was a ridiculous number of drones sold. So we kind of wanted to provide something like that, but also provide students with the background knowledge behind it, but like a simple understanding of it.
Also, see, these are some of the initiatives. The government is pumping a lot of money into this. The President's 2016 budget is to educate 100,000 new STEM teachers. You have various departments pumping millions of dollars into STEM education, specifically for providing new labs and teaching new teachers. So the task was to identify local schools, visit them, see what they were doing, what kind of robotics kits they were working with, what kind of education program they had, and then evaluate a robotics kit specialized for them, depending on hardware, software, sensors, motors. So the technical design, we went to 3 schools. Each school we went to, we spoke with faculty and students, and we made a presentation, and we told them what we were doing, and we got their ideas to kind of narrow down what our final objective would be when creating a robotics kit. We wanted to provide them with a robotics kit, develop a report for them that they could follow, and a handbook and online videos that they could follow, build the rover and the drone together, and learn about the different parts.
So a little bit of background on robotics itself is that there's a lot of schools, even elementary schools now, starting robotics programs. And so we decided, okay, let's do middle school and let's get them more involved in robotics. And so we see that, all right, so we see that they do basic math, they do geometry up to pre-algebra. That's like basic. I mean, obviously there's students that are more advanced and they go up to algebra, but we try to keep it at a basic level so that any student can get involved in this. And they don't have like a set curriculum. They just go to the class. The schools that have this program available, they just go to the class and they play with the Lego Mindstorm set and they just make it work somehow, but they don't really learn what robotics is. So we visited a couple of schools. We visited Ruben Dario, which is down the street, and we visited W.R. Thomas. These are both middle schools that have robotics programs in place already. And so we gave them a formal presentation on what our design would be and what this kit would provide them to both faculty and students, and we got really good feedback from them. So the other purpose of doing this robotics kit is the fact that the ones already out there cost a lot of money. So the cheapest one being $350, and that doesn't bring like all the cool specs on the Mindstorms, right? So we tried to make something that was going to be cost effective and that was going to be better for them to learn and to be able to actually be creative and build their own thing. So also, since these products are expensive, the classroom has one per class or something. And we want it to be where we can have at least one, in one classroom setting, have at least 3 or 4 available to them. And since it'll be a cheaper version, it'll be like a more cost-effective version, we will be able to do that for them in order for that class to be larger, because now the class is only like, we can't have a certain amount of people because we don't have enough funds for the kit for them. So
So what makes it different? We wanted to provide them. When we went, they said that they wanted a robotics kit, but they wanted something that they could transition from 6th grade to 8th grade. So what we decided to do was the Rover for the younger kids, and then when they got older, they would go up to the Quadcopter. So a cheap design that would integrate both components. So you have the robotics kit, you have the Rover unit, the Quadcopter unit, and they come along with a handbook, and then there will be online modules online on YouTube that the kids could just go and watch, or we could provide them with a disc and they could just plug it into the computer. These are some of the parts for the Rover. You have the microcontroller, servo motors, you have battery, you have an ultrasonic sensor. So the SolidWorks drawing and these are some of the components of the Quadcopter. You have the flight controller, propeller, motors. You can add on a microcontroller if you want to do autonomous flight. And then use that.
So for the compatible programming for this, we decided to go with Scratch. It's a block programming base from MIT. It's available to anybody online for free, which is the good thing about it. And it's for both Windows and Mac. So there's a lot of schools that don't have Windows, that pretty much all of the products available right now are only for Windows. And a lot of the schools are actually Mac, like they only have Mac labs and all that. So that's a plus. And so the idea of this programming also is that they get to, build they have their blocks and they put them together. But if we were to have like a more advanced class, they could upgrade to Snap, which is an upgraded version of Scratch done by Berkeley. And this, pretty much they make their own blocks. Instead of having the blocks already available for them, they kind of create their own blocks, and it brings them a lot closer to what it is to, actually program with C language. So here's a quick video on what it looks like, Scratch. If you can see, this is already made, and it's just simple. It makes the Rover go around a block. And then if you want, you just take out the whole entire thing, you go to Controls, and you go to Forever, and you wrap it around the entire block program that you made, and then you put it back in, and then it just keeps going forever and ever. They also have different, like repeat twice, repeat 3 times, as many as you want. So you can play around with it a lot. And so as you can tell, it has like little drawings. So if you want, it comes originally with a little cat, but you could change it, and you could put like a Rover, a little car, because it's a Rover, or you could put a plane if it's the Quadcopter. So it's interesting for that.
To add on from the previous video, when you actually add the forever, obviously the students are going to know it, but it's like adding a loop to the actual function, so it repeats the same motion that you started. For the handbook and the online modules, we kind of wanted to provide an outline for the students, kind of a curriculum, sort of say. The online videos, or like the previous one, where they kind of get to decide what they're going to draw or what they're going to design on Scratch and Snap, but we kind of provide them with an example, and then they upload it to either the Rover or the Quadcopter. And then the class sessions, there would be 3 different class sessions, instructions, like I said, from the outline and from the modules, and then online videos like the ones provided.
So these are some of the engineering standards. Probably the most important is U.S. Product safety. The U.S. takes product safety very seriously. So these can't be used by children, because if you come up here, you can see the soldering is still out because I had to resolder some of these. So this can be very dangerous, but there's little clips that you can clip on. There's a lot of rules you got to follow, but it's the modifications to make it child safe is fairly easy. You also have some other teaching standards. You have the Florida Sunshine State Standard. That's more for the handbook of what we have to teach them. Follow the science standards and math standards that they have. And then this is an organization that publishes journals, and we wanted to write a paper and have them publish it about the research that we did in the education and how the education in robotics is lacking in local schools and how we can improve it. This is a short video of the Rover. Some of these, because they're electronic components, sometimes you use them once and then you come back and you try to use them again and then it doesn't run exactly how it's, so you can tell it starts to curve. Sometimes I would plug it in, like I would go run it and run perfectly, and then when I replugged it in, it would just go around in a circle. So I'm not sure why. This is we couldn't get the quadcopter flying. You'll see this in the next video, but here are all the motors running. Okay.
I'm just gonna see the tape still.
Well, look, if the volume was up, you could hear the motors. They start to beep, and once they start to beep, they just take off and they all start running. Because these are very affordable motors, some of them don't run exactly, some of them run at high quality, some of them aren't as good as the other ones. So as you can see in the video, it'll just flip over. Some of them start running a lot faster at 5 RPM. So what you have to do is you have to go into the software and manually program the ESCs and the motors to run at a certain level, so they're all running at the same speed. These are some of the upgrades that we suggest. A GoPro, they can get aerial videos, a longer battery life, some extra sensors for the Rover, and a new flight controller. This one has a GPS and it has a computer program that comes with, so you can just plot where you want to go. The GPS will use Google to map it, the area, and it'll autonomously just fly where you want to go. These are some of the initiatives. We wanted to make sure that we followed current standards. We provided the manual in English and in Spanish because in Miami, that's the 2 languages you speak normally. The videos are available online, or they could be provided in a disc or a USB or something with the kit. So if they can't get online, they could just watch the videos on the disc. And we wanted to make it easy to manufacture. The boards here are made from plexiglass you can buy at Home Depot. The components, they're really cheap. Sometimes you have to spend a little more on some components because the cheap quality, sometimes they'll burn out really quick. You can't really assess the quality until you start running it and testing it.
And then finally, to conclude, in total, our design for both the Quadcopter and the Rover came out to 500. That was only a prototype. That was one design. We hope that if eventually we get this, or someone else gets this to kind of mass produce it, the cost will essentially come down a lot more. Maybe around. We want it to be lower than the actual cheapest model, which was $350. And then we also wanted to provide something that would last a student's entire time in middle school. So that's why we included the Scratch, so that would be the beginning programming. And then eventually going to 7th and 8th grade, they can move on to Snap. And then also that's why we provided 2 versions, a Rover and a Quadcopter. Obviously the Rover would be easier to program, the Quadcopter would be a more advanced level for students that are kind of above the learning curve, I would say.
These are the various people we would like to thank, especially Virgil Acuna. He's a double E master's student. He helped me a lot with the Quadcopter, even though it's still not running how it should. It seemed like every day something new went wrong, but we'd like to thank him a lot. It's probably around the building.
Thank you.
Any questions?
I think major problem with this is not enough time for the prototype to test. That's the major problem. And all these inconsistencies you complained about for servos as well as sensor readings is because of, you said actually, that cheap components. Because they're cheap, they're not reliable from unit to unit, they perform differently. And one remedy for that is you can calibrate them actually. If you had time, you could calibrate sensors as well as servos so they can perform better than they normally do. But you didn't really have time to get into that. So any other comments, questions?
One question, after doing all the work with these, are any of you thinking about being a teacher?
Maybe later on.
I mean, I would like to do outreach. Once I get into my career, I would love to do outreach with students and everything. I like dealing with students, so yeah, I don't know about teachers so much because patience level is a little, but outreach definitely.
Yeah, I think we all kind of like saw a general trend as like you're coming in as a freshman, you see these classes, intro to engineering classes are like 50 students per rooms, and then as eventually you're moving up your course outline, which is crazy, you see that the classes get smaller and smaller, and then they're only offering one section, so essentially it's everybody in the graduating class taking one section. So those are 50 students in one room, but they're only offering one section versus other classes, mainly in the main campus, you see like 10 different sections, and even those classes are filled. So we kind of wanted to keep the students in engineering, somehow feed them through the system, start them at an early age so they essentially know what engineering is about, and they're more likely to continue the process.
The other comment I had is, the kids, I know my grandson is in the 6th grade, and last year he got the Legos thing, and he figured out within an afternoon on Christmas how to put the thing together, run it. Then he decided he didn't like that one, so he took it apart and made it again, ran that one. And it was all in a kit form. So it seems to me that a big expense of that has got to be putting it together. So that if you just gave the components to these 5th, 6th, 7th grades and said, okay, build it. The part of the fun would be building it and seeing if it works. Would be cheap.
So that's what we wanted to do, but you can do that with the little gold clips that I didn't show them, but they clip on. You have to solder the gold clips, and then the clips just clip in and out, and they're really easy. So we could just do that. So what we wanted to do is provide them with all the parts, and then they just clip them in or put them together.
But the idea is for them to be more creative with their designs. So we don't want to give them like a specific, like, here, do this, you know? So we want to kind of make it available for them to be creative with what they want to do. So if they want to do a rover, you know, maybe they can make it a little different than just what we have. Or
But the basic unit that somebody would start with could be $50 if they
Right.
don't have, if you don't have to assemble it.
Right.
Yeah.
You know, and that would be affordable in a robotics school. They could buy 30 of them,
right.
Well,
and every kid could get one.
These are pretty. These mount onto this. So this has supposed to have another platform, but since they're interchangeable, but
Even
this
better.
is extra space. You can put this on the bottom, and not have this top plate right here. This is extra space. It's just for if you want to add extra sensors, or if you want to add a lot bigger battery, more battery life, so it runs longer. The top plate for the quad can run like this, but it has a top plate where the flight controller can go on, and the microcontroller can go on, and you put other stuff, other sensors. Because right now the flight controller all has is a gyros and accelerometer. So you could actually put the ultrasonic sensor on the bottom. So when it reaches a certain distance from the bottom, it'll stop and it'll just hover in place.
So you put together a manual and a video, correct? Are you going to share that with at least those 2 schools that you did voice of the customer with?
Oh, well, they want us to come back and teach the class. We're probably not going to do that, but what we're looking for is someone to come in next semester and follow up on that and build the next generation, and then have them do outreach. So they'll go visit every week and they'll teach them about the kit. We also have classes here that are taught undergraduate research or special topics where they can go, if they're studying on these kinds of things, they can go and do outreach and teach the kids about some of the stuff.
We also have the engineers on wheels, which is where actually we got the money to build this, and they do a lot of outreach as well. So if they're interested in, you know, taking some of the responsibility to go out and show this to different schools, that would be great.
It's just about getting undergraduates interested, so then they can go to middle school.
Right,
and high
because the
school.
middle schools are interested. They're really interested. So.
And one difference with these platforms is, I don't know if it came out clearly, is some of the inexpensive platforms on the market are not really fully programmable. So that's a big difference, because to teach the students the programming and stuff, we can program any way we want. But a lot of the cheaper ones actually come cooked with,
Pre-programmed.
pre-programmed, so several options, you're limited to that. You can't really teach a programming language. But these are completely open-ended, so that kind of adds value.
There's also, I believe on the main campus, it's called the Discovery Lab. They also work with robotics. I found out about them about a couple weeks ago, but they do outreach during the summer, I believe, and teach kids robotics and other engineering stuff. So that they could probably come in here and work with some of the undergraduate senior teams if some other team picks it up and work hand in hand with them to do outreach with other schools and build better kids.
Yeah, this makes engineering fun.
We hope so.
Yeah, I mean, we
The idea is to get them involved in engineering and want to do an engineering degree, so.
Well, the Quadcopter mostly gave us the most problems. And I want to hate it, but I just want to get into it and learn more, and I want to build my own now and fly it around.